Welcome to part 4 of Introductory Programming, Computer Programming with Java. We're going to take a look at this in this lesson at our first Java program. We'll also look at what Java is. In our first Java program, we're going to explore the JDK, the JVM, and bytecode. We'll look at system out print line, and then we'll cover the other items either in this lecture, but probably in a later lecture. So, what is Java? Sorry, looking up a place for dinner tonight. Let me go back to my page. Here we go. I'm back on ucjava.com, and the class, here, I'll show you where I am. I'm in ucjava.com, 32IT205, and I'll start with human to machine language. In the last lecture, we saw that computers are binary. They deal with zeros and ones or on and off switches. So in the early days, we had to actually program that way. But then the higher level languages came out, like C++ and Java. And the nice thing about Java is that it's multi-platform. You can write a program on one platform and run it on another. You can write a Java program, if written properly, that runs on Windows, Unix, and Mac. And again, I can tell you this from experience. The point of sale product that I work with during the day, we have users who run it on Linux and Linux and Windows. And it's the same product either way. So there's a lot of flexibility in that because it lets you choose the best option. Now, again, in the last lesson, we saw that we were doing some binary math. We don't have to worry about doing that ourselves. The programming language will take advantage of that will take care of that for us. Okay, a little about Java. Write once, run anywhere. I mentioned that. It runs on a lot of different kinds of hardware, servers, laptops, mobile phones, and almost anything in between. So the nice thing is a lot of the things that you're learning in this class you'll be able to reapply in many different formats. If you want to be a mobile programmer or a laptop programmer, or you want to write really heavy-duty stuff. So one of the advantages of Java as well is its capabilities. It can be used on a network, it can connect to a database, and it can do multi-threading. That is where you have multiple processes running at one time. This is very handy because while you're waiting for the user to input something, in the background you can do something else, like housekeep files or things like that, or connect out to a server over the internet. Lots of options there. Now, Java came out around 95 when security was definitely a big concern because before then, believe it or not, computers were typically not network connected. Now it's a given that they are. Now it's just assumed that they are. But when people first plugged into a modem or a network, there was a sudden fear that a virus is going to come and attack the program. So security was built into Java very early on. Lots more to cover here, but it's a very flexible language, which explains its popularity. Okay, there have been different versions, and this slide is a little bit out of date. The last major release was Java 1.5 in 2004. Since then, 1.6 and 1.7 have come out, but our class will be based on 1.5 and greater. That's when we got a lot of new syntax features and things like that. So we see that there were previous versions. 1996 JDK 102 came out. That's when people were writing mostly applets, which run in a browser. And then we had JDK 1.2 and 98, which was a huge release for Java. It had a lot of good functionality for writing applications for the PC, the laptop, or the Mac. For example, the image capture software, the color capture software I demonstrated in the last presentation, was written in Swing, which can run on a computer outside of a browser. And Swing came out in Java 1.2, also called Java 2. So that was a big release in the world of Java. Okay, sorry, one slide before. I'm now on the slide more about Java. Java is not JavaScript. That confuses people a lot, even today. The two are definitely different languages. So if you know JavaScript and think you know Java, unfortunately, they are different languages. So be careful with that. So Java can be simple, but it can also be complex. you can make it do a lot of different things. So you can use it to write a simple program that you just run on your desktop. Or you can use it to write a much more complicated program. And again, I go back to my day job, which is point of sale. In point of sale, you have software running on the cash register, but then you also have the software at the server that's sending data down to the cash register and processing transactions in real time. Lots of flexibility there, but with flexibility can come complexity. So if you have a heavy-duty application, it will be complicated. On the other hand, you could also write a pretty quick and dirty Android application pretty quickly if all you want to do is something like capture GPS. Very easy to do. So there are lots of things that Java can do. Java was started by Sun Microsystems, which has since been acquired by Oracle, but it's not open source, but it is community based. So it's based on, there's a lot of input outside of Oracle that goes into what Java is. Let's hope it stays that way at least. It was that way under Sun, and now that Oracle bought Sun, we'll hope it stays that way. So Java is free. It's free to get a JDK and a JVM, and we'll take a look at that in a moment. Okay, we saw that one. This slide's a bit out of date. Honestly, I think I'm going to skip that one. That's a bit out of date. Okay, so getting started. All you need to write a Java program is you have to have what's called a JDK. Okay, I noticed you probably noticed a little blip there. I noticed around the 6.5 minute mark my microphone stopped working, which naturally was cause for concern. So I paused, got dinner, fixed the microphone, here I am, and we'll start again. So what you need for to run a Java program, run and compile a Java program, is you need a JDK, which includes the Java compiler. And you also need a JVM, or Java Virtual Machine. So I'll bring back the PowerPoint we started with. We'll start with an editor. Something like Notepad will be fine. And then we'll run the javac command, which will take that plain text file and convert it to bytecode class files. We'll take that and we'll add in library files and run that on an interpreter, or the JVM. So taking a step backwards, the class files are platform independent. We can compile those and then distribute them and run them on multiple computers. And the reason is the interpreter, the JVM, is platform dependent. In other words, if you have a Mac, you need to download a JVM for the Mac. Same with Windows, you need to get one for Windows, and Unix, you need to get one for Unix. The good news is you only have to do that once ever per computer. Aside from updates and things like that, you only really need to do that once, and as a matter of fact, it's probably already on your computer. So as programmers, we're mostly concerned with the editor and the compiler. So let me show an example. Let's see, by the way, as we speak, I'm uploading the previous videos. I hope that doesn't cause my computer to think too much and change the audio quality of this, but they're big files naturally, so it's taking a long time to upload. Okay, I'm going to write a Java program, and what I'll do is we have to start with comments. We don't have to, but it's a good idea. So for a multiple line comment, we'll typically use this syntax, and that is a slash, and that's the one on the question key to the left of the shift, and then an asterisk. And then we'll terminate it with an asterisk and a slash. You will see a few extra asterisks in there. Those are just kind of decoration. But the important parts for a comment are the open and the close, and that's for a multi-line comment. So I'll just say here, a simple Java demonstration that shows a greeting. Okay, after that we need the class line. So I'm going to say public class greeting. Of course, I don't expect you to know what all of this is just yet. This is just an example to show how to write a program. One thing with learning Java and object-oriented programming is that there is no place to start. That's the problem. Everywhere you want to start requires some knowledge that happened in the past. So I describe this introductory course as a carousel. and we're going to take a ride on it twice. You know, where do you start on a carousel? It's a circle, right? So wherever you get on, there's somebody behind you and somebody in front of you. But you have to get on somewhere. So because of that complex relationship, what we'll do is we'll take one ride around the carousel and get a summary of everything. Then we're going to take a second ride on the carousel, and then we're going to go back and touch everything in more detail. That way, when we're at the summary level, we say, okay, we don't know what this is yet. Just here's a quick summary, let's move on. Then when we go back in the detail level, we'll say, okay, you know what a method is, so now here's more information about a method. So this course is kind of going to be first an overview of everything for the first week, maybe week and a half, and then more detailed on the second 2 weeks, on the final weeks of the course. So here we are. We've just jumped on the carousel. We don't know what public is. We don't know what class is, but just take it at this. When you start a Java program, you have to have this line, public class, and then a class name, and then an open curly and a closed curly. And I'll warn you early on, in an introductory class like this, that's very important. The open and closed curly, they have to match up. Many times somebody will accidentally delete an open or a closed curly, and that will cause the entire program to not compile or run, which is a problem. So within the open and closed curly, to make sure that it's clear where the class is, we will typically tab in one tab stop everything within the open and closed curly of the class. Okay, so we'll typically tab in once. And that way, we know we're within the boundaries of the class. The class is bounded by the open curly on line 5 and the closed curly on 13. So now I'm going to say public void main open paren string args. Open and close square bracket, close paren, open paren, and yet another close paren. Once again, this is an area where we've just jumped on the carousel. We don't know, oh, I missed a word actually, should be public static void main. We don't know what each of these words means. Public static void main, string args. We don't know why we have the open and close square brackets after args. That's behind us on the carousel. Okay, we'll come back and pick that up later. Right now, on this overview, we need to know that this is what we will call a method. A method. A method starts with what's called a signature, and that's the public static void main string args, and then it is bounded by an open and close curly. You see when I click next to the open curly, the closed curly highlights. Methods must be within the boundaries of a class. Methods must be within the boundaries of a class. In other words, I can't just add some more lines and then start typing some stuff down here. I can't do that. It has to all be within the boundary of this class. Once I'm in here, now I can say, I'll tab, every time we have a curly, we want to tab in by one. So I'll tab in by one and say system.out.println hello class. Oh, let's say hello everybody. Okay. Double quote, okay, this is what we'll call a string literal, because we literally want to print this string to standard output. And then I close with a paren and a semicolon. And once again, these are things that are on the carousel behind us. Don't worry about them too much yet. I'll put a comment. If I want to use a comment that's just one line, then I just use two of the slashes right next to each other. And again, that's the slash by the question mark. Okay? So a comment is something that is literally a comment. It is something that won't get compiled. It's just a note that we can say to ourselves. Okay? Within the comment, syntax is not important because it's not going to get compiled. I can say send a greeting to the class. Everything else is syntax and is very particular. I can't make this an uppercase P. That simply won't work. I can't leave off that paren. That will not work. So a comment, we can type whatever we want. But if it's not a comment, if it's part of the syntax of the program, then it has to follow a very specific syntax. What I'm going to do now is I'm going to save this. And it's going to ask me where. I'm going to save it in the folder 12S18IT205. I'm going to call this double quote greeting Or was it greetings? I think I misspelled that anyway. Greeting. Okay. Greeting.java, double quote. The double quotes simply mean ignore whatever the save as type here is. I'll go ahead and switch it to all types anyway. But that just means don't pay attention to the save as type there. So it won't make it greeting.java.text. This source file, again, if I go back to my presentation, this is the source file, and there are a couple of things that are very, very important about this source file. Number one, the name of the file has to end with .java. I'll go ahead and take those quotes off just so we don't get confused. The name has to end with .java in lowercase, must be lowercase. Number two, to the left of the period, that name has to match what comes after class. See, we have public class greeting. We can call it whatever we want, subject to some naming syntax conventions, but this here, greeting, must be in a file called greeting.java. That's a very significant rule. So I'm going to choose save. Okay, now that my editor knows it's Java, it colors a few things for me. I'm going to go now to Windows Explorer, and this is when my microphone stopped working last time, so I'm going to watch this one closely. Well, it looks like it's still working. Let me go to a different window. Okay. Yeah, it looks like we're still there. Okay. This is the location where this is my folder for our class, so I have our programming assignments in there, our syllabus, and also all the recordings that I've done today. We see that we have a file called greeting.java. Greeting.java. I'm going to navigate to this directory. Okay, let's see. Easiest way to do that. Sometimes you can do looks like that's not good. Oh, yes, open command window here. Let me show you that. So I'm going to hold down the shift key, right click, and say open command window here. And that's going to bring up this, a DOS prompt. Okay, back in the old days before we had things like Windows, this is what all computers look like. They started up with this DOS prompt, and believe it or not, this is how you interacted with the computer. It was all by using commands. It wasn't the visual click environment that we have now. So I'm going to type in dir greeting.class file not found. Okay. If I type in dir, we see greeting.class is not there, only greeting.java. Why is this important? Greeting.java is the text file that we create. Okay? Once compiled, greeting.class is the bytecode file that's going to result. Again, greeting.java is the file that we create. Greeting.class is what the compiler is going to produce for us. I haven't compiled yet, so there's nothing there. Okay, so what I'm going to do is I'm going to run the javac. And it'd be nice if I could just type in javac greeting.java, but unfortunately it's going to give me a strange error. Javac is not recognized as an internal or external command, blah, blah, blah. What this means is that the Java compiler is not on the computer's path, so I have to specify exactly where it is. Not a big deal, not a big deal. So I say C:\\\, JDK, I tab and let it autocomplete. So for me it's in JDK 1.5.0 and then bin. Okay, so once again, C JDK 1.5.0 bin. Now this might be different for you. It almost definitely will not be the same for you. You can install this wherever you want. When you install Java, it will ask you where you want to put it. And this is where I happen to put mine. After that, I'm going to say javac, and then I'll say greeting.java. Hit enter. I'll sit for a second. And what it's going to tell me is something very surprising. Nothing. Incredibly, that's good news. That means it worked. If we get nothing in return, it means it worked. And if we look now, we see greeting.class and June 16th, 9:31 p.m. You can't see my computer's clock, but I assure you right now it's June 16th, 9:31 p.m. So that is correct. Okay. Now that I've compiled, I can invoke Java and run this. So I'm going to say Java greeting. Hit enter. And what's going to happen now is it's going to print out the string literal that I placed into system.out.println. So Java greeting, hello everybody. There we go. So what did I just do? What I did is I just ran the compiled classes. Okay, I just ran the compiled classes through the JVM. So 3 steps. Editor makes the file, compiler turns it into class files, interpreter runs the program. Now let's say I want to change this greeting and say, hello everybody, I hope you are having a good day. Oh, nope, wrong button. And save. Okay. Now let me run it again. Let me run the program again. I'm going to arrow up and choose Java greeting. Well, the message didn't change. The message did not change because I changed the file, but I did not recompile. When I run the class file, it's going to run whatever class file is there. I need to recompile to regenerate this